Kia ora, my name is Tala O'Brien. I'm going to discuss my research, which is based on using building information modeling or BIM to enhance the circular economy in New Zealand, and in particular, looking at investigating the use of BIM in the end of life of buildings by conducting deconstruction processes. For the introduction part of my research, I discussed the concept of BIM as a powerful tool and process that is widely used in the architecture, engineering, and construction sectors. I also extensively discussed the use of BIM at the end of life of buildings to assist deconstructions of existing houses. In so doing, I also look at how to maximize these used materials to be used in future constructions. For the methodology, I conducted a case study of a real-life deconstruction and reconstruct a 3D model of the existing house using a BIM software called Revit. From here, you can see here, this is the actual house, and this is the 3D representation of the house. From the 3D model, I created the building schedules, deconstruction sequences, and health and safety processes that the team has to follow during the operation of deconstruction of the house. The objective of my research is simply to look at promoting design, smart design for deconstruction or sustainable design. Also looking at ways to reduce the overuse of natural resources by looking to make use of the used materials or recycled materials from deconstructed houses, forming a circular economy kind of system. Also, there is a potential for new economic opportunities to be explored in using of these used building materials. Here on the right hand side, you can see this is depicts a circular economy model where we're closing the loop with this dashed line from used materials being rescued and put it back into the market as opposed to being sent to the landfill. In so doing, we are reducing the use of natural resources that we have limitations on. For the results part of my research or my case study analysis, it shows some very interesting data comparing the BIM model, building elements, as well as the actual building elements that were rescued during the operation. On the right hand side here, we see building components of the house that were recovered, fully recovered at 100% recovery rate. If we are then to put this recover materials back into the market as used materials using this dollar value, this is the sort of figure we're looking to generate of $6,490.80 just for this roof, doors, and windows. So you can see here that there is actual opportunities for those looking to take advantage of this sort of business venture. So we can enforce or regulate some of these rules around this used materials. At the same time, we are saving the planet, and we are also creating opportunities, economic opportunities for those looking to as a business venture. In the discussion part of my research, I talk about how BIM is rarely used in deconstruction here in New Zealand. That's a finding I came across. There is also a need to regulate BIM mandatory in all facets of the construction, from design to construction and to deconstruction. There is also a need to push deconstruction into a more digitalized industry in terms of development of this area of research. There is a need for it, especially around design for deconstruction and optimization of used materials in buildings for the future in New Zealand. For the conclusion part, it was discovered that BIM is more than capable to execute deconstruction as a tool and as a process. There is also an increase in time efficiency, meeting all the budgets and maximize productivity, improve of health and safety for those involved in executing deconstruction, as well as the optimization of economic returns of used materials in the building market. That concludes my research, and I hope that you gain some understanding from what I have presented today. Thank you.